Let's go to guided practice 7. Consider f of x equals 2x third power minus 3x squared minus 36x plus 7. Find and classify all stationary points and points of inflection. All stationary points means maximum, minimum, or stationary inflection. So we go to y equals. We clear y1. We put 2x to the third power and minus 3x squared. Then minus 36x plus 7. y2 will be the first derivative. y3 will be the second derivative. Remember, here is y1. This is a y2. So we go to graph. Since I want to only graph y1, so go to the y equals and clear this second derivative. And I want the standard window. Since for maximum and minimum it's hard to see, you need to change the window. For the minimum, let's do negative 100. Then here's 100 for maximum. This part, scale, you just always use maximum and minimum, you divide it by 10. So we got the 10 here, we graph. It's really clear to say that maximum and a minimum. Now we will go to second trace to get minimum and a maximum point. We do second trace. Minimum first. We know this is a minimum. This is left bound. Yeah, this way is okay. Do the left bound. Then I move the arrow to the right side of this minimum point. Then put the enter. You will get the x equals 3, y equals negative 74. That's a minimum point. For the maximum point, second trace, we go to 4. Left bound, that means on the left side of this maximum point, enter. Then right bound, enter. So you get a negative 251. For the points of inflection, you could see one is very close here. Yeah, we only have a y inflection point very close to over here. We need to get the y2 equals 0. Therefore, go to y equals. This time, I will highlight this second derivative here. Then graph. I need an x-intercept because for inflection point means the second derivative equal to 0. So we do second trace, go to 2, left bound, right bound. So we get the 1/2. That will be the inflection, x equals 1/2. But we need to get the coordinates. So we do the quit. I need a y1 plug into 1 divided by 2. This point will be the inflection point. For B, find the intervals where the function is increasing or decreasing. Increasing, decreasing, which means the first derivative. If it's a positive, means increasing, negative means decreasing. So I go to y equals. I will highlight this y2. That's the first derivative. I will find the x-intercept. This x-intercept is -2 and 3. We already figured out from A. According to this first derivative graph, we can draw the sun diagram. So when x greater than 3, that's above the x-axis. So this is a positive. When between -2 to 3, it's below the x-axis. So this is negative. When x less than -2, it's a positive. In other words, when x greater than 3, there's an increasing function. When x between -2 to 3 is a decreasing function. And when x less than -2, it's a increasing function. And also you can figure out for this 3, that's a minimum point. And for this -2, it's a maximum point. So when you draw the sun diagram according to the graph, make sure if it's above this x-axis means positive, below x-axis is negative. And for first derivative, positive means increasing, negative means decreasing. Let's go to C. Find the intervals where the function is concave up or concave down. You know, concave up means the second derivative greater than 0. Concave down means second derivative less than 0. Therefore, we go to this y equals. We only highlight y3. That's the second derivative. Then check this graph. We already figure out from A, this point is 1/2. So let's draw the sun diagram now for second derivative. This is a 1/2. When x greater than 1/2, the graph is above x-axis, so this is a positive. When x less than 1/2, the graph is below x-axis, so it's a negative. In other words, when x greater than 1/2, it's a concave up. When x less than 1/2, that's a concave down. Let's go to guided practice 9. Consider f of x equals e to the x power over x minus 1. Find the y-intercept of function. For what value of x is f of x defined? For the a part, we just need to plug a 0 into function. So we go to y equals, clear y1 only, alpha y equals, enter. We have a second divide, that's e to the x power over x minus 1. Then I will quit. Go to alpha trace. I will put 0 here. So 0, -1 will be the y-intercept. This is a rational function, so x cannot be 1. In other words, x equals to 1 will be the vertical asymptote line. Let's go to C. Find the sign of the first derivative and the second derivative of the function, and comments on the geometrical significance of each. So we go to the first derivative and clear y1 and y3. I only need a y2. For the y2, check window. We need a standard window first. So zoom 6. This is a standard window. We do know there is a vertical asymptote line for x equals to 1. Therefore, we need to figure out the x intercept. So we go to second trace, 0. Left bound is over here, right bound here, then enter. So you had a 0, x equals 2. We can draw this sign diagram now. You have to draw the vertical asymptote line. That will be 1, positive, because it's above x-axis. If it's between 1 and 2, that's a negative. If x less than 1, it's still negative. From this sign diagram of the first derivative, f prime of x, we can decide in which interval is increasing, which interval is decreasing. When x greater than 2, the first derivative is positive, means increasing. Between 1 and 2, this decreasing. When x less than 1, is decreasing. Now let's draw the second derivative, sign diagram for second derivative. So I go to y equals, clear this y2, that's equal sign. Then we need a graph for y3. y3 means a second derivative of the function. So we go to graph. We do know when x equals to 1, there is a vertical asymptote line. So when x greater than 1, you could say all the graph is above x-axis. When x less than 1 means the graph is below x-axis. According to this second derivative graph, we can draw the sign diagram for second derivative. Here is 1. If x greater than 1 is positive, when x less than 1 is negative. For the second derivative means concavity. Therefore, when x greater than 0, the graph will be concave up. When x less than 1, it's concave down. Let's go to E. Find the equilibrium of a tangent at the point where x equals 2. And I will go to alpha trace, put in 2. This will be the coordinates for this point. And we put alpha trace, go to y2 to get the slope. When you see this, that means slope equal to 0. That means x equals 2 is a minimum or maximum. We already know that this is a minimum point. Therefore, the equilibrium will be y equals 7.39. Let's go to the last question. For 6a, the following diagram shows the graph of f of x equals e to the negative x power. Point A, B, C, D, and E lie on the graph of f. Two of these are points of inflection. We know that B and D are the 2 points of inflection. And for 6c, find the x coordinate of each point of inflection. So you go to y equals, clear y1. You will get the second divide, then power. Here is a negative x squared. Inflection point means your y3 equals to 0. So only highlight y3. Then graph. We need to figure out this x-intercept. We do second trace, 0. You will move this to the left, enter, right, enter, then enter. They give you the points. Then do second trace again, do the 2. Left bound, enter, right bound, enter. So you get the other inflection point. That's at 0.707. Now let's go to 6D. Use the second derivative to show that one of these points is a point of inflection. We know a point is a point of inflection has to satisfy 2 requirements. First of all, the second derivative equal to 0. Secondly, there is a sign change for second derivative at that point. This is the graph for second derivative. We got to draw a sign diagram. Here, I will draw 0.707. That's a x-intercept. For second derivative, is this point. If for x greater than 0.707, the graph is above x-axis, so it's positive. When x less than 0.707, it's a negative. We have another point that is a negative 0.707. So when x between negative 0.707 and a 0.707, it's a negative. Using this sign diagram, because this sign diagram shows that second derivative function has a sign change at 0.707. And also we know that for second derivative of 0.707 that equals to 0. They satisfy these two requirements. Therefore, 0.707 is a point of inflection.